Turn the mics up. Hey, NK8 Brad. Pie.
That's a raspberry?
That's a Raspberry Pi. Okay, so we're going to go ahead and start. John's going to join us here in a minute. Are y'all ready to go in the chat room? There's Michael. That was KB8ZUN. I think I answered that in the last session. Potentially, but we need to get some cross-pollination between the two systems to be able to get it up, to get the DV tool and DVAP tool to talk with the other non-trust server-based systems. Oh, good. Everybody's ready. There's KE4E&I, John in Atlanta. All sorts of folks all over the place. I wonder where the furthest person is today in the chat room. Put your current location, and we'll take a look at some of these. Scotland, Dundee. I know who you're talking about. You know, the Scottish, they seem to have taken over Reflector 1. I have to get the marble removal earmuffs when they start talking on Reflector 1. It's kind of hard to understand them sometimes. We've got Wales, Ireland. Don't even know where that is. Maryland, Michigan, Florida, Texas, Manchester, Ohio, Denver, Montana, Carrollton in for FWD Tom. Hey, from suburb of Atlanta, Powder Springs, Toronto, Lansdale, Ventura, Hermitage, New Orleans, well, Australia, that might be pretty far, Copenhagen, Ohio, England, Cumming, Alabama, Sydney, Missouri, New Mexico. Wow, all sorts of folks on here. So I guess we should probably get started with the presentation. This section is going to be John and myself are going to give it. I'm going to start out talking about dongles and DVAPs and D-Star advanced topics, and then he's going to come in and show some of the more homebrew type of boards that are on. And then hopefully we'll have a little time for a few questions. I don't know if y'all saw the schedule. So this is D-Star 201, dongles, DVAPs, reflectors. Oh my, I had to say that. Sorry about that. Then D-Star 301 comes up after that. That'll be John and Ed talking about DRAPs and IMCOM use. That is really cool stuff. And they've got a whole DRAT setup ready to go. It's going to be very impressive. Then we'll have another roundtable and answer questions. And then after that, there's a net. And who knows what else might happen in Memphis. Somebody correct me on the correct pronunciation. And is it
Memphis?
See, the locals are saying Memphis, but I think I've heard it's really pronounced Memphis. Memphis. That's a hard one to. I can't quite get that in.
Depends on how close to Graceland you are.
It's like in Georgia we have Savannah, and when you're from Savannah, you talk like this. Okay, D-Star Live 2012. We're going to switch over and talk a little bit about.
Your little third off?
Yeah, pull the third off if you would. That was good. You put that third up and I didn't even notice. So parts of this, some of you have seen in Dayton and Pacificon and other presentations, and I kind of pulled the best from different presentations that have been made and added a few additional toys that we're playing with. That's probably why some of y'all are here today, to look at some of the toys. And so let's get started looking at the bits and bytes of D-Star. Boy, is that easy to read for you? I can see every, I can't tell one or zero on the whole screen there. But as you saw this from Ray's earlier presentation, this is actually a full key up. When you bring up your HT And, oh, you can't see when I talk there, can you? When you bring up your HT and do a very quick key up, this is what happens in D-Star. It sends out a bunch of sync ones and zeros to say this is just starting a new transmission. And it sends out at least 64 of those, and on some systems even more. And then there's a special, you can see in black there, header sync frame that's a 15-bit special value that says this is the beginning of a D-Star header. And then in this 660 bits that follow is the actual encoded header plus voice and data. So the red portion there, you might be able to see on the right, it's including flags that say this is from a radio versus a repeater. There was an error when when you key up on your radio and you see it come back with question marks or other symbols. That's because one of these bits got set either by the repeater, local repeater, remote repeater, or a radio. It's trying to tell you something by setting one of these bits. And then there's the 4 magic fields: my call, your call, repeater 1, repeater 2. Those are the key routing fields in D-Star. And after that, you start seeing the voice and data interleaved. So with D-Star, you can't do voice without data, and you can't do data without voice. It's always in there. There's 9 bytes of voice and 3 bytes of data every 20 milliseconds. So you see here in the first frame that says frame seek, that says this is the beginning of a voice transmission, and it has a special value that says that so that the radio can say, okay, I'm going to start now playing, sending the audio through the codec, that AMBA codec that was mentioned earlier. And so it takes the 9 bytes of voice information, which is there in green, and sends it through to the codec to be able to play out to your radio, and then 3 bytes of data. And those 3 bytes of data include lots of different things. There's a duplicate header in there. So if the header gets squashed coming in, it actually gets duplicated periodically in the data stream as there is space for that data stream to hold it. It also, when you have GPS data comes in this section. When you plug in a serial device, like a terminal into your radio or a PC into your radio, that data comes across. And each type of data has a different prefix that says, this is the GPS stream, this is the duplicate header stream, this is local user data, this is the special byte that says whether I want to listen or not. There's all sorts of special fields in there, and that's usually the first byte. I don't know whether you can see that first byte in every other packet tells it the next 5 bytes that follow are this type of data. And then at the end there's that frame sync, and as we mentioned before, there is a special frame sequence. It's actually 2 packets, not just 1, that says this is the end, and that's what causes your radio to beep. And this is the expanded version of the green and blue that you saw there. The 9 bytes of voice every 20 milliseconds, and the 3 bytes of data. And there's the header that's expanded out, flags again, and the magic, that it's almost a mantra. My call, your call, repeater 1, repeater 2. You always put, interestingly, you put your call in the my call field. So I put my call in the my call field on my radio, and I put CQ, CQ, CQ in the your call field if I just want to talk anywhere or do any of the linking or routing that John talked about earlier. And then the repeater 1 and repeater 2 fields are there for routing information. Repeater 1 is always what's the hop that I'm going to now, which is usually the module that you're speaking to. So if you're on the B module, as in this example, W4DOC module B, that's our 440 repeater, that would be in repeater 1. And repeater 2 is where does it need to go next. I can actually crossband repeat on my repeater from the 440 to the 2 meter, and it'll never go through the gateway computer. It goes in the RF module to the controller and then back out, so it's never seen by links, and that's something that's done trickily by some folks to not be heard on a linked system. Boy, I shouldn't have given away that little tidbit, should I? So usually, and we tell everybody to always put a G in that 8th character in the repeater 2, because that says send it to the gateway. And then the gateway computer, which is Linux based, makes the decision as to where it needs to go next. It can go back to another module through the gateway, or it can go out the internet to do call sign routing, or that's where D Plus picks it up and tries to figure out what you're trying to do. Are you linking? Are you just talking? Are you sending text messages? What are you trying to do with that? This is what a D-Star frame looks like. So there again was the bit synchronization, the ones and zeros at the beginning, the frame sync, flags, the mantra, my call, your call, repeater 1, repeater 2. There's a checksum at the end to verify that it's good. And then interleaved voice and data. And this came out of the original JARL document that was translated from Japanese to English, and not quite right, it's 72 bits and 24 bits, not bytes. So for the D-Star knowledgeable hackers out there, you would have noticed that on that example. The D Plus is something I came out with when D-Star first came out. There wasn't a lot of functionality that we were used to as FM repeater owners, like putting out an ID on the repeater, doing an echo test. Am I making it into the repeater or not? Being able to go across the modules to link for a net. None of those features were in D-Star. So D-Star is just a binary protocol, and it rides the network, so you can sniff it on the Ethernet segment and see what it looks like. And we figured out how to do that, and then figured out how to play back. So if you put the echo test command, which is an E, in the last character of the your call field, and you talk on your local repeater, it will typically echo back whatever you say. And it actually stores that file on the system, so system admins make their repeater IDs like that. They do an echo test, they save the file, and then they take that file and they replay it periodically, once an hour, once every 6 hours. That's how they make announcements. One of the interesting things that we did for the Atlanta Radio Club, where I managed the D-Star repeater there, W4DOC, is we took all of the users that had D-Star radios in the club, and we had them key up their radio and say W4DOC digital repeater. So each member of the club that had a D-Star radio now was able to hear themselves ID the repeater. So once an hour, a different member of the club's ID is played out. And that really made it interesting for club members, and actually brought a few more club members in and converted some of the FMers over to D-Star. Hi. So as you can see with D+, it adds those features plus simulcast to all modules. Script execution, which is really cool. You can, if you give it the right your call field, you can have it run a shell script on the system, and that could go out and pull a current weather report, or emergency bulletins, or ARL bulletins, or whatever you want, and send them back over the air. You could have it say, what's the current temperature of the system in the shack, and it's unlimited. I guess it's limited by your imagination, but otherwise it's unlimited as to what you can do with that. As I mentioned, it allows you to record voice and data files, so you can send those out as messages to be periodically played back. Same thing with text messages. You can send out a little text message that says, repeater, computer network, system network in 5 minutes or something like that. Again, only limited by the imagination of the people that are on the local system. Then we added the ability to link the repeaters together so we could have people talk between systems. There was a network that I think K6BIV was a part of. It was the first scheduled and longest running D-Star net. If he's in the chat room, maybe he'll tell us the stats on that. But it was between the K6MDD repeater in San Francisco up on Mount Diablo and another repeater up in Canada. And every Sunday they linked their two systems together and had a net. And then that also provided the ability to then have reflectors, so we could have more than just two repeaters talk to each other. Now you can have, as you saw earlier from the ref30.dstargateway.org status page, you could have 30, 40. At Dayton, we had 150 repeaters and I think 150 users, so 300 total linked into the reflector one year. So lots of interesting stuff there that D Plus added. And then the products that we came out with were really based on what do we want to do personally. It wasn't, can we make a commercial product? It was, I want to connect from my PC just like I do an Echolink and talk and listen on the D-Star system. And as was mentioned earlier, I think by John, the AMBA codec from DVSI is the only proprietary part of D-Star. So we took that chip. You can see on the right here, the big chip is the AMBA. We put the 2000 on it, which is a full duplex version. The 2020, AMBA 2020, is what's in most radios. It's half duplex because you don't need full duplex for a local RF radio. And then this is a Atmel ARM7 processor, and it processes all the packets and all of the protocol that chip requires. And then an FTDI USB chip, and that's why you have to go and load the FTDI drivers, because that's the chip that we use to connect to the PC, and then the small mini USB connector. And you can plug that into your PC running Windows or Linux, or you can plug it into a Mac, all via USB. So that gave us the ability to sit at our PC and talk on the D-Star network. Well, I got tired of sitting on my PC. I wanted to be able to get up and walk around the block, walk around the yard, walk around the house. So we came up with the DV Access Point dongle. And let me give a shout out right now to Mo Wheatley, AE4JY, who's a double E visionary. He's a really awesome engineer, and I kind of came up with here's what I want to do and kind of the chips that we'd like to do, and he's overnight he says, oh, well, is this it? And he's just an amazing person. So he came up with the hardware designs for both of these devices. And so the DV Access Point dongle, when it came out, added the, you see the FTDI chip there on the left, the same Atmel chip in the middle, and then we replaced the AMBA chip with a Analog Devices RF chip. And that chip would do 2 meters. It actually has a very large frequency bandwidth, but we set it up for 2 meters, and it has decoding. Excuse me, I'm probably talking too fast here. It does digital encoding and decoding, so it has a GMSK modem functionality built in. So that's how we can take that stream of ones and zeros that are encoded via GMSK. It comes in through the SMA port there and into the Analog Devices chip through a filter network, which is specific to the band that you're on. So you've seen that we came out with a 70 centimeters. We had to completely redesign that filter network for the 70 centimeter version. And then you take your HT and you talk to it just like you would a repeater. Same commands that you run on your radio to link and unlink and do the other commands, you can now run on this access point. Plug it into your netbook and a Verizon Air card, put it in your car, and drive all over the world, and you're still on the D-Star network. And let's see, a few updates here. Things that have been added to DV Tool over the last year or so. Auto reconnection. One thing we found is that internet connections are really bad. You may or may not know your DSL or cable line is somewhat flaky. It's dropping packets left and right, but because it uses the TCP protocol for most of the things you care about, like web browsing, you don't notice it. It just kind of stalls, and it takes a little bit longer, and then it comes back and everything works. Well, the voice packets from D-Star, as well as other voice over IP protocols, use UDP, or datagram protocol. And it's just rapid firing those packets out, and there's no notice of dropped packets, duplicate packets, packets out of order. It's just rapid firing, so there's no correction in the line for that. So that's all has to be handled by the software on each line. So we added auto reconnection so that when your internet connection gets a little flaky, it'll reconnect back to the reflector or gateway that you are connected to. Added some command line options so that you can now set up a shortcut that gives you the ability to just click on the shortcut link on your desktop, and it will automatically open the device, connect to a gateway or reflector, and then you don't have to go in and start clicking on things to connect to your favorite gateway. So some people have 6 or 7 different shortcuts, one for each reflector they like to go to, and one for their local repeater. It's also notifying the name server on Connect. That allows it to do something similar in the future to call sign routing. Right now the DV Tool protocol, which is based on D+, doesn't do call sign routing. That's a function of G2, because G2 has the huge database of where everybody is that gets updated every 5 minutes. We don't do the same thing because it would be prohibitive to download that entire database constantly to your system. So we've started putting in the groundwork to be able to do the equivalent of call sign routing with dongles and DVAPs, and also to be able to connect amongst users. So you don't have to just connect to a reflector or a gateway. You could potentially connect to another person's dongle or DVAP or hotspot device. Another problem we found with the internet connection is several ISPs will return dummy answers. So if you go out and say, what's xyz.a.com, they'll give you an IP address for that even though it doesn't exist. And that's because they want you to go to their page that has advertising on it so that you'll click the link and they'll make money off of that. So we had to figure out when the ISPs were spoofing the DNS returns coming back when you're looking, for example, for reflectors. We start looking for reflector 1 through now 58. So we go a little bit further to see if there are any new reflectors out there, and some of the ISPs were returning an IP address for reflectors that didn't exist. We added multiple name server support, so if one of the D+ name servers went down, that it wouldn't take the network down. So standard IT methodology for doing redundancy in the network. They're located in separate geographic areas and all run the same protocols. And as you can see there are a few other fixes that were added to the system. One of the cool features there is the Bonjour network functionality. And Bonjour is a protocol, it's really zero-conf networking that Apple took and gave it its own name brand. And that's the ability on a local network to broadcast that you're there and what services you offer. So we'll talk about how that's used in a few minutes. It's pretty cool. Same things were added to DVAP tool, so we'll show that off in a few minutes. D+, the reflector network, those were also enhanced. So we were seeing some problems on gateways that had underpowered CPUs. The recommended minimum is 2.4 gigahertz, and some people were putting their gateways on netbooks with a 1.6 gigahertz Atom processor, and that was causing some problems trying to make it through the 30,000 entries that are in the user database. So we were able to make that use less resources, so on underpowered systems it would work. We also added some redundancy to try to remove black holes from DStar. You've probably all experienced or heard of black holes when somebody just goes off the air and you don't hear from them for another minute or two. And those happens for a variety of reasons and in a variety of places. So we added some duplication to try to get around that. But there's still in some areas of the hardware the ability to have black holes. You still experience those. So let's go on and look at some new stuff, and I'll show you these in a couple of minutes. But one of the features that the Bonjour added was the ability to put the dongle and DVAP and hotspots as well on one of these devices, like the BeagleBone you see on the left, which is an $89 complete Linux computer. And that's using a TI ARM processor. And it runs complete Linux distribution. It's a very cool device. So now you plug your dongle or DVAP into that, and you put it on your local network. You run the server that understands the Bonjour protocol, and it automatically tells every other computer on your network that you've got a dongle and or DVAP there. And the new versions of DVAP tool and DV tool understand the Bonjour protocol and will see that and let you use it. So, for example, from my home, I rarely use a dongle on my local system. I've got a Raspberry Pi that I plugged in on the network somewhere. I'm not even sure where it is in the house now. And when I'm on a dongle or a DVAP, or I need a dongle or a DVAP, I just point to it with DV tool using the Raspberry Pi. And the Raspberry Pi is the board on the right. You've probably heard all about that, and some people are sick of hearing all about that. It's got a lot of press, but it's very cool. It's a little $35 Linux computer, and it was developed in England to help promote electronics and computer science with kids, so they wanted to make it as cheap as possible. But it's really taken off in the technical community as well, and most of my friends have at least one of these devices, and they do everything from the equivalent of an Xbox Media Center. They run their dongles and DVAPs on it. They make it their primary desktop for Linux. It has on the right a couple of USB host ports, an Ethernet port. On the bottom is a HDMI, so you just plug it into TV or HDMI monitor. It has baseband audio and video and an audio connector there as well. It's a very sweet little device. There's also a USB, I think it's an on-the-go port for a device. You plug it into a PC and it comes up and looks just like a USB flash drive. Let's see, what else did we add this year? Oh, Android thing support. So in a second I'll show you the task of the day, which is some support for dongles and DVAPs, probably the DVAP first and then the DV dongle for Android devices. One of the cool things that Google did was to add USB host support to Android phones and tablets. and those let you plug in a dongle or DVAP or any other device, and if you don't mind programming at the low-level USB protocol, you can incorporate that into your app. So I'm hoping in the next 2 or 3 months to have a application for the App Store, and the minimums there is you really need Android 4.0 or later. There's some new features in 4.2 that give you Bonjour support natively, and I thought about using those and requiring people to have 4.2, but most devices don't. If you buy the Nexus type of Android devices, you get 4.2 the quickest, but then you typically wait a year for any of the vendors to come up with that. And anything older or newer than 4.0, 4.04 works fine. WA1PJG. Well, that call sign's hard to say. So that should be just fine. I think the best support is going to be a 4.1 device. It adds a few more features that can be utilized. One of the problems that I found in Android was that it had somewhat incomplete USB device support. So, for example, when I plug in a dongle or a DVAP into a PC, I can get the manufacturer name and the device name out of the USB header, which is a part of the USB protocol standard. But Android didn't have that functionality, so it's something I actually had to go into the Android operating system, the Android open source project, and make modifications. And I've got patches submitted to the Android source team to add that functionality. And one of the patches they added, which was a problem with the notification of devices being plugged in, I submitted that patch a few months ago, and that's actually made it into Android 4.2. So I was pretty pleased with myself, actually, that I've got code now running inside the Android operating system on 4.2, and hopefully they'll accept the other patches that I've got, so that it'll be easier to tell when you've got a dongle or DVAP plugged in. The problem there is that we use the FTDI device, which is used in everything that you can think of. The ICOM radios use them. The USB to serial devices use them. Just about everything that wants to talk serially to a PC uses either the FTDI device, or there's another CP device that is very popular. So we need to know whether it's a dongle or just one of these other generic things. Maybe someday you can plug your IC92 radio into an Android tablet and have it programmed remotely from Ed Software on D-Star Info. Wouldn't that be cool? Okay, maybe 2 more things. We talked a little bit about the 70 centimeter DVAP. This took us a little bit longer to develop just because 70 centimeters seem to resonate perfectly for the board size that we have to give us a whole lot of noise. So we had to completely redesign the way we do filtering, the chip filters that we use, a couple of little firmware changes to get the 70 centimeter DVAP working. But it's out there now and does 421 to 450. If you're in IRU region 1 or 3, you're going to get 430 to 440. I think that's the limitation for those. And one of the things that's interesting, we see Mark, KJ4VO, at HRO in Atlanta. He's more of a D-Star-holic than I am, and he has at least 2 dongles or DVAPs plus a dongle or DVAP. So he's typically got 3 devices plugged into his laptop, running those all at the same time. So now he's really happy having a 2 meter, a 70 centimeter DVAP plus a DV dongle. And now let's see if we can switch over. Let me switch to this little camera, and I'm going to show you. This is the DVAP. As you can see, it's a pretty small device. The 70 centimeter units say 70 centimeters on the back, So that's how you tell the difference between the two now. And then there's the DV dongle, and we have engineered this blinking green light. It's hard to tell because it's going through a blue case, but that's a green light, and it's on the bandwidth that your eye sends to the brain to say, buy me, buy me. So every time you see that flash and you don't already have one, somebody in the room here is saying, did you mean bite me? No, no, no. Buy me, buy me. So let's see if we can do a little demo. And here is the DV dongle. This is the DV tool software, so we're talking right now to the DV dongle, and we're going to open the device. And what that does is it opens the device. You can see there is a name and serial number. It figures out that you're actually talking to a DV dongle, and it sends information up to the D+ server to say, hey, please, I'm on the net, please give me the list of all of the latest reflectors and gateways. And it also says what version you're running and what operating system you're running, so the D+ server can tell you whether you're running the latest version. And the current latest version is 2.0 beta 5, hoping to release 2.0 final shortly. I know that's probably going to be one of the questions later. So if we come up on reflector 30.
We need to get you something for your throat.
No, I'm good. We are now connected to reflector 30, and somebody out there, I'm sure, is going to key up. There was Kent, and turn up the speakers here on the PC. And there was KJ4VO.
With echo?
Oh, there's K6BIV on his dongle from California. Everybody in the chat room is now rushing to connect their dongle or DVAP into and see themselves. And remember that we are delayed probably 10 to 30 seconds, so that's why some people are keying up and unkeying, because they're not seeing themselves. Okay, some of the features here that were added is the ability to go in and it queries the system you're linked to. So on reflector 30 here, you can see all of the repeaters that are linked in. You can see all of the dongles, which includes dongles, DVAPs, and hotspots. And if they have keyed up, it puts the module they're on and a colon there. Oh, and there's, let's see who just keyed up. Well, the easy way to find out who just keyed up is go to history.
I'm on DOT listening.
And you can see in this history list all the people that are keying up in real time. And I noticed some of these call signs from the chat room, so everybody is trying to get on TV right now. You can also see the data. So you remember we talked about the GPS data that's in the stream, and it's designated as that type of data in the stream. Well, here it is on the screen. So with the DV dongle and DV tool, we'll turn that down a bit. You can actually see the folks that are running a device that have GPS, so a 92 with a mic, an 80 with a GPS mic, or a 31 that has GPS built in, or a 2820, or any of the devices that have GPS built in. Those are the standard NEMA strings. And if you go to the reflector page, like ref30.dstargateway.org, you'll actually see the people that have GPS, their call sign will show up in orange in the last heard list. And you click on that and it'll show you where they are in the world. This is also the way that you can tell when people are talking about you behind your back, because they'll send little text messages to each other that nobody else sees, unless you've got a dongle or DVAP. or a PC plugged into a radio running the ICOM software. This also allows you to go in, let's disconnect, look at some of the different features. There's so many reflectors and gateways out there now, so we recreated a favorites list. So you can see I've got reflectors 1, 30, 2, 14, and then the local repeaters that are in Atlanta. So you can, from this list of all systems, make your favorites. And then over on the connection page, you just click favorites, and it will only show you those in the list. The other thing we added was the look and feel. So I can now go in and choose Mark, that's KJ4VO's favorite color scheme. Or, let's see, there's a black on pink. There's Connie, KB0ZSG. We made that pink color scheme for her. And one of the interesting things for the programmer types out there, you can make your own color scheme. So there's a discussion of how to do that out on the DV Dongle website. So let's move over now, if we can, to DVAP Tool. And you'll see here in DVAP Tool that it's much more minimalistic, easy for me to say, because the whole point of the DVAP is to be able to get up and walk away from your PC. So all you have to do is put your call sign in, the frequency that you're running in hertz, and open the device. It does the same thing, queries the device, makes sure that it's the right type of device, goes out to the D+ name server, says give me the list of all of the systems I can connect to, checks the version, and then you walk away. And all of the commands that you use from then on are from your radio. The your call field is your friend, and you link and unlink and do echo tests and info commands, all the things that John and Ed and Ray talked about earlier that you can do with a repeater, you can do with the DVAP. So that, rather than bring that up, the folks here are getting antsy to jump back in. And
I was just kind of, once you open it up on
yeah, I was scared. Ed is sitting in the background waiting for me to connect somewhere so that he can key up and make some snide comment. So we're not going to do that, but we're instead going to switch over now to a couple of other interesting devices before we give it to John. And so you've seen the DVAP. We showed you that earlier. Well, what is that? We're prototyping a new case for the DVAP and maybe some other new toys, and looking at laser cut acrylic, and it's basically the DVAP board that's just been put in a laser cut acrylic, and it's actually pretty cool. You don't want to go back to the red case once you have one of these, and in fact I'm already being blackmailed to get one to a few friends that have seen it in person. The other thing, this is the Raspberry Pi board that we talked about earlier, and you can see there the HDMI port, SD card, everything, the operating system runs off an SD card, so there's no memory on board, and it's just a super cool extension of the DV dongle and DVAP to allow you to take a $35 board, put it on your network somewhere. Here's the BeagleBone, the $89 device. It has more, I like this one probably a little bit better just because it has more expansion, so you can add a lot of things to this. We showed off at Dayton plugging a DVAP straight in to these expansion headers. So we had a dongle and a excuse me, dongle and a DVAP at the same time sandwiched onto this device. And it's pretty cool. The one thing it doesn't have is a graphics interface, no HDMI. So this one you get to via SSHing in or via web page. And there's also a DVI cape that you can put on it as well. So what other cool tricks can we do? So y'all may have seen this device. Take the stand off. This is a Nexus 7, and it has this cool little connector on the bottom, micro USB, which allows us to plug in a special USB on-the-go cable, this little bitty piece right here, and then we can plug in a standard USB mini, and then if we get lucky and the demo works, see that? It is actually powering the DV dongle. So now you carry this around, and in fact, this is the Nexus, the Galaxy Nexus phone. It has the same port on the bottom, and it'll do exactly the same thing. Imagine plugging your dongle or DVAP into an Android phone and taking that with you wherever you go. And then the real trick was we've started doing the programming, and you can see that this dongle device, the serial number and the boot and app versions came up, and it queried that directly out of the device. So that's the current active project is working on an Android application. And then for those that are exceptionally rich, this is the 10-inch Nexus 10, and this is probably the nicest tablet I've ever used. I've got an iPad as well, but this just feels great. It has higher resolution than the current device. Show that. And it's got big batteries, so be able to plug a dongle or DVAP in and run it for a day or two, and that's going to be very exciting. So I think that's all of the toys that I have to show here. Next up is John. Let me bring him in, and John will show you all sorts of cool things. Do you want me to move that to point to you?
Let me see if I got audio here.
I'll say something.
1, 2, 3. Hello. QRZ. I wanted to show you very quickly before we finish up our hour here. We're going to, if we'll bring the little camera or however you want to do this, Robin. I just want to show, we've had a lot of discussion about node adapters, and I want to show you the one here. Do you need your handheld cam to show this a little better? This is one of the Moencom boards. It's the node adapter board. I think it's based on the Dutch Star.
Okay,
let's switch over to...
I need to switch to, I think that's it right there.
Yep.
Are we up?
There
we go. All right, just to show you the board here, and it has two cables plugged in. I've mounted it in, what else but an Altoids 10. It will fit in there nicely. I have a little rubber base on there so that it doesn't contact the board. And using the connectors here for the 9-pin serial connector, which goes to the radio. And that is just going, what I'm demonstrating here is this can be used in a couple of ways. One, as a hotspot, similar to the DV access point, but I'm going into an FM radio. This, in fact, is a Yaesu FT8800. I'm going into the packet port, and I'm going into the 9600 baud packet port so that I get a nice flat in and out from the discriminator and the modulator. And so I have a serial cable connected, or a USB cable connected to my laptop here, and then also have the connection to the packet port on the radio. And then I'm using some software called DVAR Hotspot. And if you can come over here maybe and just show the screen a little bit. I'm not going to try to demonstrate a whole lot with it, but I am connected to Reflector 30C. And you see the activity coming up on it. And so if we had everything configured up, moving equipment around in here has been kind of challenging today. We're showing so many different things. But if we had everything all configured, you would see, you could hear this on a regular FM radio, or not an FM, but a D-Star radio, and you see the activity coming up on the screen from reflector 30, and then I could also be transmitting. So this gives you a lot higher power capabilities that you can walk away. Some people have connected these up to antennas at sites to get a whole lot more range out of them. And since this radio would run 50 watts, I believe, on 2 meters, of course you'd be limited by the radio that you're going in with it. It's not a full repeater, however, it can be used as a higher powered hotspot. Now, you can take this same configuration and using the sound card in here and a laptop and some different software called, I think it's called GMSK Client. And who's that available from? Isn't that Jonathan? Jonathan Naylor, I believe, is the one that did that software. And I can make a D-Star radio out of this. Now, it's not as compact as one of these radios you normally see, a commercial radio, but using the sound card in here, and I'll usually have my Logitech USB headset going into this and into a radio, and this could be an HF radio, or here I have the dual band VHF UHF. It can be a full D-Star radio. Now you have to be very careful with your deviation. Ray mentioned that, and Robin I think mentioned that earlier on, that you have to be very careful about your deviation because you're working on a radio that is normally working with 5 kilohertz, plus or minus 5 kilohertz deviation, equivalent to like a 12.5 or 15 kilohertz bandwidth channel. So there's a lot you can do with these. This board is available through Moencom, MOENCOMM.com. Jim's a nice guy to work with and everything. You can even buy some of the cables that go with it, mount it in an Altoid stand, and have a lot of fun with it. There's a lot of good information out there on the internet about how to hook it up, how to have fun with it. So I think we're going to take another break. We're going to come back in just a minute, and we're going to talk about MCOM, and we're going to do DRATs. And we're going to be doing some live stuff with DRATs. We'll invite you to connect in. We'll configure it, get it going, and we'll have some fun with that. So we're going to go away for a few minutes. We'll be right back.
Questions while we're waiting.
Robin will be on chat, or are you going to be live?
I'll be live.
He'll be live here, and he'll answer some questions while we're setting up on that. And we'll be right back with DRATs and MCOM.
Hey, Robin.
Hey, what?
There's an interesting link posted in the forum on a serial cable from Red Park for the iPad and iPhones. Are you familiar with that?
There is, in fact. I really wanted to do the iPhone, iPad first. Apple likes making money. Apple likes making lots of money, and they like making it from you. And in order to plug a device in to an iDevice, you have to pay them money. You join their Made for I program. You give them more money, and you do some development, and you give them some more money, and ultimately you can make your own little thing. They don't like generic things, so they don't want you to plug a dongle into a generic device that then goes into the iThing. So I've been to the last several iOS developer conferences, Apple developer conferences, and I've talked to all their Made for I people, trying to figure out an easy way to get the dongle and the DVAP plugged in. And they introduced me to the folks at Red Park, and we talked about it. Unfortunately, the speeds aren't there on the devices, and the Red Park is, I think it's also only a serial device, so it's not a USB to serial type device. But at the time, the device they had would not do the 230 kilobits per second that's required. So in the last year or so, Apple has now come out with the newer generation of devices that have USB host capabilities. But again, you join their Made for I program. They give you the secret sauce on how to turn it into a USB host. Then you have to develop your non-generic hardware and pay them some more money, and then they'll let you sell your devices as long as you then pay them some more money. So that's a much longer process than I wanted. They also want their lawyers to talk to your lawyers before they even let you join the program. So it's a big deal to go to an iDevice. So that was one of the thoughts behind going to the Raspberry Pi and the BeagleBone, is I can plug those devices into my local network, and I can write the iPhone or iPad device or application for those devices just fine, not have to pay Apple anything, put it up in the App Store and not have to go through the hassles. It doesn't get the device plugged directly in, but it's the next step towards doing that. The much easier thing is the more open Android platform, which lets you plug straight in, program to it, and walk away. So imagine you have an old, beat-up Android phone that somebody has given you because they're now 2 generations later. You plug your dongle into that, it provides the dongle over wirelessly to the iPhone, and now you've got a device for your iPhone. So we're looking at all sorts of ways to make the iPad and the iPhone work with the dongle and DVAP, and indeed hotspots, whatever. We're just trying not to make Apple too much richer as a result.
I got 2 questions for you, Robin.
Okay.
First one is, can you do GPS through a DVAP? I mean, through a DV dongle.
Through a DV dongle. Actually, I get that question for both the DV dongle and the DVAP. Right now, the answer is no on the DV dongle. Obviously, you'd have to plug in some type of serial GPS device to give you the NEMA string that could then be parsed and added into the data stream. But even then, it wouldn't get picked up by DPRS, which is Pete Lovell's software, because that's on the repeater listening to the RF side. So I've been working with Pete on providing a link into his APRS to DPRS network to be able to take that data and use it so that from your dongle you'd be able to use a GPS device. But the more interesting question was, what about a DVAP? You've got a 31, you key up, it's automatically putting the GPS string in. That's going out through the system so everybody on the network can see it. Again, it's not being picked up because it's not RF into a repeater, which is where Pete's software, the D-Star Monitor program, is looking. So again, I'm working with Pete on coming up with a mechanism to connect DV-Tool and DVAP-Tool straight into his gateway so that when you key up, it'll show up. The other question I've been asked is, can you put the location in a static box in DV-Tool so that with my dongle I can tell them where I am? And in fact, once I've got the protocol worked out with Pete to be able to do that, I'll add that functionality to DV-Tool, and you'll be able to just type in your lat long, and it'll automatically transmit that out when you key up.
Hey, let me throw one question in. It came in by email, which is a little different than the chat room. I don't know if it's on topic for this discussion, but it's D-Star. Here's a question. It's from Robert, N1 SSH. He says, I'm very interested in D-Star radio. I live in Newport, New Hampshire. The closest D-Star repeater is about 30 miles away. Is it practical for me to get into D-Star radio? And would I be able to get into the repeater from here?
That's a good question. Probably depends on the lie of your house and the repeater, whether you could put up a Yagi that points to the repeater that would give you enough gain to get into the system. We get into the W4DOC repeater 30 miles out when we're mobile, so you might have a chance of doing that. The other thing is you could go with a dongle or a DVAP, and as long as you've got an internet connection, you can connect any of the systems, including that repeater that's 30 miles away, and talk to those folks.
I think a good rule of thumb on that is the range is going to be comparable to an FM repeater, plus or minus, depending on the conditions. So if that repeater is similarly equipped as other FM repeaters in that area, for example, height above ground and power, etc., the range should be about the same. And repeaters, you see them from anywhere from 5 or 10 miles if their antennas are low to the ground to 50, 60, 70 miles if it's a high site. So I look at the comparable coverage of repeaters in that area, and it should be about the same.
Well, one of the viewers mentioned hotspots. Is that an option? Hotspots in the area?
In fact, that's one of the most popular things in the Northeast, in New Hampshire and Vermont, is putting up small local hotspots on their hill and providing D-Star access to that local system.
Now, one thing to remember on a hotspot, it's not a repeater, so it lets you get from your mobile or portable station to the D-Star network, but you're still talking simplex to other stations in your area. So it's not a repeater, and it's not going to function as a repeater if it's a hotspot.
There's an interesting point here, WX4ADX, hello, state where you are next time it comes up, mentions about using a Logitech headset. When you've got a dongle, it's always best to use a USB headset for your audio. One of the things that we found is that every sound card on a laptop and a desktop that's factory installed is typically not that good. They have crystals that aren't quite on frequency, and they drift, and you have to play some games to keep everything in sync with the audio coming in and the audio that you send out. So when you put a USB headset on, it is clocking on the USB clock to give itself the clock. And that's a perfect frequency. It's very well clocked, so you don't see glitches in the audio as it goes on, and it gives you incredible quality audio. Some of the best people you hear on D-Star reflectors are people that are on dongles coming in from like a Logitech ClearChat, and they have a ClearChat that's wireless. So if you want a poor man's DVAP, go get a Logitech ClearChat wireless, and you can walk 30 feet away from your PC and still be talking on D-Star.
Here's one thing to add to that. If you are using a DV dongle and you get on a reflector and ask for an audio check, please get it from 2 or 3 people instead of just one, because those of us that got radios, we end up turning up the volume so we can hear the DVAP. But then when somebody comes in, the DV dongle, but when somebody comes in using a radio through a DVAP, their audio level is much higher than a lot of the DVAPs that just check with one listener.
That's an excellent point. You really should, before you get on the air and transmit with a DV dongle, in the setup tab, there was an audio section where it has audio loopback, so you can do just baseband loopback through the sound card as well as through the entire system. So it'll take audio in from the mic, send it through to the dongle, encode it in the D-Star AMBA format, bring it back out, send it back through the dongle, have it decoded, and then out the sound card through your headset, your speakers. And that tests the entire system. So it's a once through of the entire system, and it helps you to make sure that your audio level is proper.
It said the DV tool here also has an audio meter that can help you to get your audio the right level.
That was one of the features that we added, is in the lower right-hand corner. There's an audio meter to make sure that you're not too low or too high. Just like the audio meters that we're using here to make sure that our audio sounds good coming out over Ustream.
Okay.
I saw Orlando, Florida on WX4ADX. Hi to Orlando. It's probably a little warmer there than it is here in Memphis. We've seen some snowflakes flying past this afternoon here in Memphis.
You still haven't got that right.
Say it right.
You got to say Memphis.
Memphis. Okay.
Got to get the Elvis thing.
Memphis. We're going over to Graceland.
Okay.
We're in Memphis.
Tom, I know I switched my computer around on and off the network. Have you got my PowerPoint you can bring up?
Well, let's see.
I hope I didn't get a new IP address and mess that up. It's a PowerPoint slide. I think I see it there.
Should be QDX.
Yeah, it's still there.
Is that it there?
Good deal. Good deal. All right, we're going to talk a little bit about low-speed and high-speed data for a little while. And reviewing just a little bit, 4,800 bits per second is the complete digital stream that's being transmitted. and of that 1,200 bits are allocated for data. As you can see on there, every D-Star radio has a serial port included. It's a 3-pin, transmit data, receive data, and ground. So it's very easy to connect with one cable. If you can bring the camera back on just a minute, Tom. If you bring the camera back, I just want to show how simple this is. I've got one cable connected to my serial port. If you don't have a serial port on your computer, use a USB to serial adapter. And then it's connected here with my 92. Works the same if it's any of the radios. You just have the cable that goes to it. So you can do that with one. I went back to the PowerPoint. I'll get our directors back there to get us back going. Now remember, this works simplex as well as through repeaters and reflectors. But when using data programs, you need to remember to go into your settings and disable the GPS. There are several GPS settings in there, and you want to make sure that you disable those. Get this a little closer. Okay. Is this microphone working well? I think it is, if I get a little closer there. Thanks for the feedback.
They couldn't hear you in Greece. So.
In Greece? Well, it only was making it just out into the Atlantic, so we're doing better now.
It looked like the audio bar was only getting...
Okay, how are we doing now? Is that better on that one, Tom?
Yeah.
All right, using low-speed data, remember there is no error correction over the air on data transmission, but in programs like DRATS, which we'll be showing here shortly, the error correction occurs within the application. Just like with packet data, it's sent. If it's received, has a good checksum, it sends essentially an ACK back to let you know. It will work simplex as well as through local repeaters or even linked repeaters. So in an emergency communication situation, you can use this simplex and have a lot of the data capabilities, which are tremendous within the radios. And then, of course, you have the GPS position data if you either have one of the GPS-equipped radios or one that you put a GPS speaker mic on as well. I showed you the easy connection to the radio, single cable, no TNC is required. So laptop and radio, that's the setup I have here, we'll be using. DRATS.
What other settings do you have to set?
I'll be going into that. Thank you, sir. DRATS is, now here's what hams love. It's a free, easy to use, multi-platform data communications package. Does a lot of different things: messaging, email, file transfer, mapping, position reporting. And we owe all that thanks to Dan Smith, KK7DS, who has done a wonderful job with DRATS and its continuing enhancements. DRATS can be used for simple data communications between one or more stations. Great tool for supporting MCOM. Also, if you just need something to display the position of GPS-equipped stations on D-Star, you can use that as well. DRATS, I said, is multi-platform. That means it'll work on Windows, Mac, or Linux. You can take multiple interfaces to it. You can connect a D-Star radio. You can go in via the internet without a radio. You can use a DV dongle. Or some limited AX25 capabilities have been built in to work with a KISS TNC over an FM radio with a TNC connected. And we'll talk just a little bit more about those capabilities. Here are the major functions of DRATS. You have the messaging, which includes email. You can even send WinLink 2000 messages. You can do radio messages in a lot of different formats. Something that's becoming a lot more important in supporting served agencies is the ability to do forms. Those of you who are getting involved with that understand the ICS 213 form. These forms are built in to DRATS, the ICS 213, as well as the NTS radiogram. And how it sends those forms is that the template is on each end, and you only send the raw data over the radio or over the internet, and then it populates that form on the other end. And with some XML programming behind those forms that can be created, you can have a printed form that looks exactly like the ICS 213 or an NTS radiogram or a number of other forms. The chat capability gives you just very simple chat between multiple stations. It gives you quick, simple, keyboard-to-keyboard communications, multi-user, but you can also create private channels. Just want to caution you on that. Your message still goes over the air, but in the DRATS program, it is filtered out if you're in a private channel where it only displays those messages. And then finally, well, not finally, but the file transfer. Here's a feature I really do like about DRATS, and I underline unattended file sharing, because normally with if you're sending files from one location to another, you have to coordinate the sending and receiving of that file. With DRATS, and I'll actually demonstrate that in a little bit, I can either upload a file to another location or download from that other location without any operator intervention on the other end. And then mapping and position reporting with GPS, and the maps are included in the that it can be downloaded with the DRATS software. All right, there are two types of data that are being used on DStar, and within, you actually can use it within DRATS as well. We're actually going to demonstrate DRATS, and we're going to do it two ways. Now, the first thing I'm going to do, I've got Ed, WA4YH, across the room, and we're going to do a radio to radio. And right now I am on a UHF frequency.
Can I go back to camera on this?
Go back to camera right now,
okay,
and be ready to come back to DRATS, because we'll demonstrate it. I have my IC92AD tuned to 445-350 simplex. I'm in DV mode, and I am connected. Now I'm going to switch over to the DRATS program, and we will be able to do some messaging between us. I'm bringing up DRATS. Now, one of the things you'll see very quickly is once you load the DRATS program, there's a couple of things you'll need to configure, but they can be done very easily. First thing I'm going to do is go to my preferences. You see I put in my call sign. Now, here's an important thing. This does not have to be your FCC call sign. I'm not sure whether we mentioned this in any of the earlier sessions, but DStar in the protocol sends your call sign, which is the My Call field, with every transmission. So if you're an anonymous kerchunker on repeaters, your days are numbered. We're going to know every time you key up, because that call sign is displayed on all the receiving stations. Now, the call sign that's here on the configuration screen can be your actual call sign, or it can be a tactical call sign. So it could be Shelter 1, it could be EOC, it could be John's Radio. Right now I'm just looking like a packet station with almost an SSID, because I have multiple stations, so WB4QDX-1 is my call sign. The next thing that you're going to need to do is the paths. And the only thing that is really significant here is the file transfer path. And what you're doing, you're designating a folder on your computer, your local computer, where that the files that you will either use to originate to send to another station, or that they're going to be downloaded into that folder. Now let's go into some other things. I'm going to come down to radio. Now you'll see on my screen here, I've got a lot of radios defined. And a radio can not only be a radio, but it can be a network connection to a ratflector. We'll talk about ratflectors. And it could be connected to a TNC. So right now, I'm going to uncheck everything, and I'm going to check the one that is already predefined for my 92AD. Now what I've done is I occasionally go in and we'll have to define one. So I'm going to show you an example of that. You hit the Add button. You're going to give it a name, and that name corresponds to over here on the right side of the screen. You're going to define the type. If it is connecting to a radio or a TNC, it's going to be a serial connection. Otherwise, it can be a network connection, and that's going to go out over the internet, like you're talking to a ratflector or to another station via the internet. TNC, dongle, or AGWPE, those can all be defined. All right, right now I'm connected to my 92 AD. I'm not using the internet for anything, but I'm going to go into the chat screen, and the first thing I'm going to do is go over on the right side, and I'm going to right click, and I want to ping all stations. Now, what I should get in that is those stations will answer me back as to who is out there. And so what you could not see that we'll show if we need to on here is that I actually transmitted. So Ed, are you connected over there via your radio?
I think so.
Did not see you answer. So I'm going to ping again, and my radio will actually send out a ping request. And if you look at the very bottom of the screen, it might be kind of hard to see, but it'll say that I pinged a station. I just transmitted. I should see him in the station list over there if he answers me back, and I did not see him answer me back. So I'm going to let him play with that part a little bit and get that working again. We've been transferring a lot of computers around in configuration, so we'll get back to that. I'm going to try it one more time if you're ready for me. I'm going to send out a ping request. I transmit. I hear it on another radio over there, but I'm not seeing a call sign answer me back. All right. While he's configuring that, I'll let him do one thing here to make sure that he's connected to the right thing. Disconnect from the internet and connect to your radio. And we're on a frequency of 445.350 and DV mode and simplex. Paul, KJ4G, I'll give you the information for the DRAT stuff in just a little bit, and we'll talk about that. All right, I want to ping you one more time, and if that doesn't work, I'm going to move on, and we'll come back to it. I just pinged. How it should work, I should see his station come up over on the right side of the screen.
Give me a couple seconds, and I'll be back with you.
All right, I'm going to move on out to the internet right now. Now, I want to go back to... I want to show you this screen right here. Whoops, find it. All right, we're going to do two things. If you're out there and want to try DRATs, there's two ways that we can get together, and we're going to get together on the chat screen first. First off, if you are on a DVAP or a dongle, or on a radio that's connected to a repeater, if your repeater or you are connected directly to reflector 30D, as in Delta, you can reach us by radio. If you are only connecting via the internet, here is where you need to set up a network in the radio configuration. dstarlive.dyndns.org. I'll come back to it. Let me see one more time. Let me see if I see a receive from you. So while people may be setting that up, okay, I think I saw you that time. I'll come back to it. Those are two ways that we're going to be setting that up. I have actually configured a RATflector, or this is contained in the software. It's called Repeater Proxy, but affectionately known as a RATflector because any station that comes into it is reflected out over any of the ports that are connected. Now, at my home in Atlanta, I have a RATflector running on a PC. It is also connected to a 2820 radio that is going into WD4STR port C, and port C is linked to reflector 30D. So what we have done is link anything on reflector 30D or anything that comes in via an internet connection on dstarlive.dns.org is all going to be shown. So now I'm going to switch to...
One more time on the address.
dstarlive, no spaces, no hyphens, anything. dstarlive.dyndns.org. I'm using the dynamic DNS alias to get to my IP address.
Okay, I just had to put it in the chat room. Paul can't write that fast.
Oh, somebody just... Oh, you put it in there. Thank you. Very good. All right, Paul, you should be good there. Paul's a great user of D-Star and D-Rats down in the North Florida area as the section manager for North Florida. All right, I'm going to switch over to D-Rats now. And first thing I'm going to do is go back to my preferences. I already have this set up, and you see I'm going to check the internet connection for dstarlive.dns.org. Save that. Now, I'm going to see what happens here. Look at all the stations popping up over on the right side of the screen. And, boy, there's a bunch of people out here waiting. We're on the chat screen right now. So if you send a message, if you just type in something there, you're going to see those start popping up. If someone types something we're on the chat screen. There we go. I'm seeing some stations. There's hello from Collierville, Tennessee, W5EMA. Thanks for the message. Now, if I type hello from Orlando, wow, it's really working here. Now, I don't know whether some of these stations are on the internet only or if you're on a radio, but all are tied together. So this really works well. We're even getting someone connecting in. I think that's Michael from South Australia. My friend Dan over in Dallas, Georgia, and also Jerome. So good to see all of these folks on. Now, this is the chat screen. If anyone types in, everyone on this connected sees this. So it works very well for just simple chat. Now, I want to show you something. I'm going to go over to the Files tab, and right now you'll see this looks kind of like an FTP screen. You see the local side on the left side. That's my local folder that I defined in the Files section for sharing. And then on the right side, if anyone defined that, I could come over here on the right side and pick one of these stations. But you'll see one on this list. If I ping, it'll come in, and I'm going to get a whole bunch of stations here responding to my ping. But I'm looking for one in particular that's going to show up on this list. Look at that list change. Of course, you're going to see this a little bit late. Now, one of these entries on this list is not a call sign. Right up here, GWN-Aries. Now, that is another instance of D-Rats that I am running out there on the net that I'm using in a sense as a file server for our Gwinnett Aries group. Now, if I come up here and I want to connect to that, I'm going to select GWN-Aries and I'm going to connect. Now at the bottom of the screen it'll say connecting to Gwinnett Aries, connected, and what popped up on the right side of the screen, but the file list that is on that server. Not really a server, just another PC out there. So I can upload files to that station or I can download from them. For example, no one is on that computer at my house, but I'm going to take this, it's a 1 kilobit file, namefile.txt, and download. And if you watch at the bottom of the screen, it will start that process of transferring that file back to my local computer in the file that I have set up, the folder I've set up locally. So that has now completed, and you'll see in just a few minutes it's been received, and you see the file shows up on the left side of the screen, namefile.txt. So I can do the same thing of sending up to it. So you can imagine in an emergency communications environment on that, if you had a place that you needed to have a central repository for files, for shelter reports, whatever it may be, that would be a great place as kind of a repository for files. But that could also be another station. If someone would tell me on chat that they have a folder set up and I'd like to send or receive a file back from one of the stations out there. If someone will tell me on chat real quick that they have something set up that I can connect to, I'll just do that and go to an individual station. I'm going to disconnect. While I'm waiting for that, I'm going to disconnect here and wait to see that. I'm going to take a chance that
WBS-2.
I'm not seeing that update.
67 WBS-2.
Go to your chat window.
I'm looking at the chat window.
You got
Oh, I'm not in my chat window. I'm sorry. The chat window on...
DRATs.
I'll go on DRATs. I was looking at the other chat window. Okay, check my files. KC7WVS. So I'm going to go back to files. Look for him on the list here. KC7WVS. Where are you? There you are. I'm going to see you there on the list, so I'm going to pull you down. KC7WVS. And I'm going to connect. Let's see what files he has stored out there. Oh, he's got a bunch. So there's a bunch of good things out there. If I want to go grab this file called ICOM cables from him, hope you don't mind if I grab that. And I'm going to download it. If you look down the lower left corner of your screen, it's starting the file transfer. That's a 21 kilobit file. I don't know whether you're on radio or directly on the internet. Doesn't matter because all of them are linked together. So that's sending. Now you'll also notice, even though we may be connected via the internet, it's not connecting or it's not transferring at real fast speeds like you would with an Ethernet type of file transfer, because you have injected in this, whether you're going over the internet or whether you're going over radio, the kind of ACK and NAC type of protocol that's a part of that. However, that file should be coming down. There, it showed up in my list. Thanks to KC7WVS-2. You can see that's easily done. Somebody enterprising could grab something off of mine as well. Now, let me go back. I'm going to go over to the event log tab. This is very valuable in that you have a log of all of your activity going on from this session. And if you're in an MCOM situation, what are you always told? Log all your stuff. Log everything that you do. So you can log file transfers, messages that automatically come up in the log, or this can be used as a troubleshooting tool as well. Yes, sir.
I'm going to jump in here real quick, John. I was reading a report from the Colorado Springs, Colorado Fire MCOM event. And one of the comments that was written in the report was the served agencies needed better note-taking and better logs. DRATs would provide that for them. And the other comment was they were going to train more of the volunteers that were helping them to become scribes to be able to document as much as possible. It would be easy for this to become the scribe for them.
Absolutely. Absolutely. In an automated way, error-free, because it is actually doing the work for you, kind of behind the scenes. I'm going to go over to the Messages tab. This can be used for several things. Number one, if I want to come down and say New, now I get several things. I see some ICS 213, two different varieties of the form that is stored there. These two forms, one is ICS 213 US, one is a Washington County ARIES variation of that they've customized. You see the HICS 260 message. I think that's a hospital form that is transmitted. You see memo, radiogram, and Skywarn is one that I downloaded from Patrick in Pennsylvania a couple of days ago that could be used as a Skywarn reporting form. But let's say I just want to send an email type message to a station. Now, I can send this to a regular SMTP type email address, and because it's going through the RATFlector, it'll get to the internet and it can send that message. Or I can send it to a station that's out there, or I can send a WinLink 2000 message. Now, I know my friend Jerome is out there in Atlanta. I saw him responding a minute ago. So I'm going to send him a message, and he should receive it here shortly. I'm going to put in WD4CWG. That's all I have to put in for the destination call sign. I'm going to put test from Memphis. And I'm just going to say, hello, Jerome. And I am going to send this message. Now, I'm going to switch over to my outbox, and you see the message in there, test from Memphis. I have a configuration setting in there that it's automatically going to send it after a period of time. I will say it will not send it out to him if Jerome is not on the station list. It will hold that until he shows back up. So it will hold that message until he comes up as an online station or has pinged or something on the network so that it knows he's there. And it has now sent that message. You see it left my outbox. Now, Jerome, I'm going to go back over to chat. You should have received that message, and you can let me know if you would that you have that. Now I'm receiving a message. Someone's sending me one. It looks like W5EMA is going to send me one, and so I'll look for it in just a few minutes.
Now, John, I want to interject in here because this is one of the cool things about DRATs. You have your call signs placed inside the software. Everybody else, if they're on an RF ring, their DRATs will see that message. Their radios will see the receive light come on. But DRATs will ignore that message if their call sign doesn't match what was in your to call sign field.
That's exactly right. In fact, during our simulated emergency test in Gwinnett County, Georgia, back in October, we actually did a lot of messaging as a part of our exercise that we were doing, sending messages from remote locations. Now, we used FLDigi, which is a great software package for sending messages. It will also send forms. But here was the thing with FLDigi. When you're sending it out, and we were even sending them over a repeater, when you sent them out, everyone received the message. And you had to determine whether that message was addressed to you or not. DRATs, as Ray was just explaining, even though the message went out in the data stream over the repeater, only the station it was addressed to will actually see it come in to their email inbox. Now, it looks like I've received a message. How do I know that? Because my message tab up there has turned blue, which means there's been activity in that section. Was there something else you was going to say, Ray?
I was, but it didn't have to do with the particular message. It had to do with the form, so we'll get that one in a minute.
Okay. Let me see. Was this an old message, or this was one that I think was sent earlier? I thought I saw that I had received a message, but I'll come back to that.
Come on, open one live.
Well, I don't have one. Oh, I'm in the outbox. I'm sorry. There, W5EMA. You see sender W5EMA, recipient, that's me, and the subject. So I'm going to open it up. And what he sent me was an NTS radiogram. So you'll see it in the form here. And it will automatically do a check for you. You just put in the text that you want to transmit, and it will calculate the check digit for you in that. He selected routine. There's the message. Gary, thank you from W5EMA for sending me a message and proving that it works. And you sent it as a form. Now, over the air, it didn't send all the graphics of that form.
Yeah, that's where I was going with this, because Dan was real smart in realizing that the data rate, it's only 900 bit per second. You can't do that much with it. Well, programming in a Wi-Fi world, they're exactly right, because that 900 bit per second will choke.
That's right.
But if you've got the form, I've got the form, everybody in our group has the form, you don't need to send the form. You just need to send the field header and the data that goes in that field header. And then when I bring it up, and you're going to show in just a second, when you go to print, while it might not look like the form that everybody is used to seeing on your screen, when you print it, it will.
Now, if you'll switch back over to my computer, Robin, here's the radiogram. When I hit print, it comes up as, because that part's written in XML, it comes up as an HTML graphic in the browser. There's my radiogram, which looks an awful lot like the standard ARRL radiogram form. So if I print that, just like printing an ICS 213 message for my served agency, it's going to look like the form that they are used to seeing. So great feature. You can customize, you can add your own forms, you can build a quick form just for transmitting the data back and forth. For example, if it was a shelter report and you just wanted to know the occupancy, number of beds open, anything like that for any time during that. But if you need to get into actually printing a form in the format, the look and feel that they use for their form, you can put that in there as well.
And there's a question in the forum here: has development stopped on DRATs? No,
it has not. There are the current release is 0.3.3. However, if you join the DRATs users mail list, and there's information on the drats.com website, you can also have access to some daily builds that are betas that are putting in new features and correcting bugs and things like that. So development does continue with DRATs.
And not only that, it is open source. Dan's got the source available, and he welcomes anybody that's a coder that writes good code to come join him and help build some of the things. And I know I've sent a few comments to him that I would like to see added to it. We were doing a demonstration out in Washington with N7SS, and the comment was made, well, we've seen the buoys for the coastal lines that Dan had incorporated a script that would go and pull the buoy information. Well, we asked about what if we could do river levels. And within an hour and a half of sending the email to Dan, he goes like this, and we were able to see on the mapping, which you'll get to a little bit later, where it would populate with the river levels and give the warnings for the flood stages on those river levels as well on the maps.
That's exactly right. So there are a lot of capabilities that, number one, can be built into this, as well as things you'd like to do on your own. But very simply today, this is a very full-featured program that can be used right now, and I think does a great job in supporting emergency communications.
Can you also show real quick the STMP for regular emails?
Oh, if I want to send...
The other letter's in the wrong configuration.
Well, I'm going to do two things. I'm going to send an email, and if I want to send... I use this program during one of our nets that we have in Gwinnett Aries on Monday evenings because we have multiple nets going on, and one of them is a WinLink net. So if I want to send a WinLink message out, it's going to find a path out to the Internet and go to a winlink.org address. However, all you have to do is go WL2K : and then if I want to go to WB4QDX at winlink.org, that's going to send that message out. And I'm going to send, or I can do a send via, and I can send through one station if there's just another station on here that has internet connectivity, or to my RATflector. It can be used that way to get to the Internet for either a standard SMTP message, for a regular email address anywhere in the world, or it could be sent to a WinLink address just as well. So a very, very full-featured program that we have with this. The other thing I will show you is the map. And I think I don't have any data in here for this because I entered some new information. There are features within the mapping to display stations, and they will actually show up on maps that can be downloaded, available as a part of the program. If you go into file, let me see, where is it? Oh, I know where it is. It's in the program itself. In the folder when it installs, you'll see a utility in there called Map Downloader. And you can actually download maps for the different parts of the whole U.S. where you might be operating, and it will display the GPS information that comes in from stations. It will show that on those maps.
And that mapping software is everybody's favorite price.
Free. All right. Lots of good things there. If I want to go back to show the thing with just two stations connected directly together, and where I don't have a repeater available, this is just two stations that need to connect together. I'm going to go to radio. I'm going to disconnect from the Internet part of it. I'm going to connect to my 92AD. I'm going to go back to the chat screen. I'm going to clear this screen because we've seen everyone here.
I can give you a position report.
Whatever you'd like to do, but if you'd like to send me some information right now, I am looking at you on chat, ready to receive it. Now I'm going to come over here also, and I'm going to ping, which should, well, first should clear out all of these stations. And there's WA4YIH. He's reported that he's online. You see him in the top right. He's on the station list. It also showed as set in the configuration to send a message when he's now online. If he wants to chat with me, he can type something in, and it will show up on through my radio. And again, we're not using any repeaters. We're not using the internet. We're just strictly going radio to radio. Here's simplex. It could also go through a repeater. It could also go through linked stations, through a reflector. But be very cautious on that, and I'll get to that in just a second. But as you can see, let's switch back to the screen. Ed has sent me a message. If I want to, do you have folders configured for
Yes.
file? So if I go to files over here, there's WA4YH, so I'm going to select him. Let me just make sure he's there by pinging him. And you heard him beep maybe across the room. Make sure I'm disconnected there from the last station. Go to WA4YIH to connect to him. Did I hit connect? There we go. Connecting to WA4YIH down the lower left. I am now connected, and I also got his list of files that are in that folder. And if I want to go grab this Georgia Airport codes, I could just go out here and say download, and it will start that process over the radio. Again, this is not going to be a fast way to do it, because effectively it's a 1200 baud channel, but you effectively get a throughput of about 900 baud, or 900 bits per second on that. So it's not the fastest thing. You may want to send pictures, but pictures are going to have to be low resolution pictures if you're using them over the low speed data channel. Now I'm going to switch back here. We've seen that going on. We know that'll work. Let me get back to my presentation here. And let's move along in here to, let's talk about 1.2 and the high-speed data DD mode that is available on the ID1 radios. We're operating in the 23 centimeter band, which is 1240 to 1300 megahertz for amateur operation. It is a shared band, so we have to contend with some things there, but there's a lot of bandwidth available there. The band plan allows for multiple bandwidths, so we're operating the ID1 in DD mode. It's a much wider bandwidth, which also affects the distance that it will travel. The wider the signal doesn't go as far as a narrow signal. Hams have been in the 1.2 band for quite a while, doing ATV, crossband links, and there have actually been some repeaters that are located in the band as well. Remember, at this high frequency, you're actually getting into microwave frequencies, or SHF band, super high frequency band as it's called. It becomes a lot more line of sight. You are affected a lot more by obstructions, and so your propagation and your range are definitely limited. Just to give you a comparison, if we can go back to the screen, I've got looking at what is your free space loss. No obstructions, 5 miles in the 2 meter band, you're going to lose 93, almost 94 dB of your signal going out 5 miles. Let's move up to the middle of the 70 centimeter band, and you're going to lose about 10 dB more. Now let's go all the way up to the 23 centimeter band, and you're going to lose another 10 dB. So you're talking 20 dB more attenuation in your signal from the 2 meter band to the 1.2. So as you can see, it is a lot more
you need to be a lot more line of sight, and it is more dependent or less range that is available. However, where it can be really advantageous is if, say, your repeater is at a high location and you have almost line of sight to that repeater, or another way that I'll show you that we've used 1.2 is sending photos from the air, from an aircraft in the air. All right, to get on 1.2 and in using the high-speed data mode, you're going to need the ICOM ID1 radio. You saw mine over a little earlier, the configuration that I have. It will operate standard FM, or in the GMSK mode, it'll operate as either regular D-Star 4800 BPS data stream over the air, or it will operate in a higher speed mode, a different emission, and give you 128 kilobit transmission over the air. The ID1 has an output power of about 10 watts, so it's not as powerful as your 2-meter radios running 30, 40, and 50 watts as well. In the high-speed data mode, an ID1 is acting as basically an Ethernet bridge, wireless bridge. Unlike a lot of other radios, on the ID1, to go into the high-speed data mode, there's actually an RJ45 plug on the output of the radio, and it will connect in to a computer directly, or to a router, the WAN port on a router, whatever the case may be. It can be used for internet connectivity through a repeater that is equipped with a DD module, or it can be used to create a wireless bridge between 2 points in the field. Now, when you're communicating through the DD repeater, you are actually using it as an IP address over that, and it's usually a 10.x.x.x, some 10 address, and that is the address that when we were talking about registration earlier in the program, that is the IP address that you'll use, and that's assigned to you when you register. Yeah, there's the RJ45 connector on that radio. Alright, where can you use the high-speed data mode? It can be used to give internet connectivity. It can be used for transmission of larger files, including photos, or you can set up a wireless network between 2 points. If you look at some of the photos here, this was one of the uses that we used during an SET back in 2008, I believe. We were actually out measuring stream gauges. You may remember back in 2008, the Southeast was in the middle of probably the biggest drought in 100 years, and yet our exercise was simulating what happens when you have flooding. But we had to be prepared for that. So we were tasked by our EMA to go out and read stream gauges. Now, the picture on the lower right was an interesting situation. We had 12 sites where we went out and measured the stream gauge. In the 12th location, they said, we can't get there. We can't get to the bridge. Our EMA director was standing there with us, and he said, well, they must be at the wrong location. We sent GPS coordinates back. Yes, you're at the right location. Well, why can't you get to the bridge? There's a gate across it. We'll go around to the other end. Well, there's concrete barriers across it. They can't get to the bridge. He went back and consulted his aerial data, which is updated every 6 months, and he said, yeah, I can see the bridge. The road looks clear. We said, well, we'll send a photo back. And we sent the photo that you see in the lower right back via the ID1, which shows a gate across it that someone had constructed on this property. So it impressed him that we had real-time photos from the location and could send that back, and it updated data that he pays, I'm sure, a pretty good amount of money for, to update aerial photos for every bit of the county. The Ethernet connection, here's some information on how to do it. I want to show you. If you, without you may have wondered why I have the router in the configuration that you saw earlier. those of you who work with the computer some, we're used to just plugging into a network, and DHCP on our network gives us an IP address. Well, with the ID1 and with the DD network, we need to be using that particular static IP address, that 10 address, that was assigned to us. And so we either need to go back in and configure our network card or our wireless for that 10 address, that specific 10 address, as a static IP. And you can use any DNS for that. The easier way to do it is if you have a router, connect the Ethernet port from the ID1 to the WAN side of the router, just like this, and program that static IP on the WAN side. And then use the router on the LAN side to either give you a DHCP IP address, or you can configure it any way you want there. This way, I just either connect wirelessly or connect to one of the 4 LAN ports on it. It gives me address, and I don't have to make any special configuration for my laptop. And so I can either be wired or wireless from my laptop back through the ID1 back to the internet or to the other station. So this is an easy way to do this. So I'm going to find my power connection down there as we keep going. I mentioned real-time aerial photos. What you need is an ID1, a D-Star repeater that has a DD module, and suitable digital camera. Some of the newer cameras have GPS built in that will add the coordinates to the metadata within the photo. Obviously you need an airplane. We actually constructed, this was a Cessna 172, and we actually used, there's a small, about an 8-inch diameter aluminum inspection port right under the back seat of the aircraft, and we mounted a 1.2 antenna, which is very small, on the bottom of the fuselage. We had the operator here is KF4PWI Scott, with actually my ID1 in its loose configuration. In the airplane, we flew, we took pictures, he inserted the GPS data in there manually. We used the Google Picasa site to upload the internet pictures to the internet using the ID1. We also used, because we had essentially an internet connection between the aircraft and the ground, we also used DRATs for a chat session, because in the aircraft, if he was trying to use his HT or another radio, it would have been very, very noisy. So he takes the pictures, we upload them to the Picasa site. Now if you look over on the right side of the website, you see all these little bubbles to show where they were taken. Picasa will also, if you click on that, it will give you a thumbnail over the location where those pictures were taken. So we actually flew about 50 miles up to Athens, Georgia, and took pictures all along the way. One of the pictures was of the University of Georgia football stadium, and we have a normal picture of it there. And one of the things with the Picasa website, you can go back and get the Google Earth photos, so you could compare a previous picture to, let's say this was a post-disaster picture taken. You could see a before and after. And this was one of the things. Here's the Google Earth photo of the same area. Now, you can imagine how this might be received by served agencies. In fact, about a month after we had performed this exercise, I had an opportunity to brief the Georgia Emergency Management top officials, and one of the questions came up was, can you take photos from the air and send them back quickly? And I said, yes. How are you doing it now? Well, we have sat phones. They send it at 9600 baud, and we usually have to land the airplane to send it over the sat phone, and said we can do that from the air. They said the governor really liked that, and I have to say that was a key point in us receiving almost $300,000 in funding to equip a lot of sites around the state of Georgia for that. So don't discount the ability to use amateur radio to help build other infrastructure, especially using D-Star to help you out. We're about at our time for another roundtable session, I believe. So we're going to look forward to your questions. They'll be coming in as we get the group back in here. But we'll be watching for any questions that you have. So for the next hour, I believe we have another chat session going on. And then we're going to have a live net coming up at it'll be 4 o'clock Central Time. And